You know, we're swimming in light every single second of our lives, but we almost never stop and think about how it actually works. The fact that you can even see me right now on this screen or see the stars at night, it all boils down to a few really amazing rules of physics. So today, we're going to dive into one of the biggest ones. What happens when you bend a ray of light?
And let's just start with a super simple question. You've seen this a million times, right? You stick a straw in a glass of water, you look at it from the side, and it looks broken. Why?
It's that classic optical illusion. The straw looks like it's snapped in two right at the water's surface. But of course, if you reach in and grab it, it's perfectly fine. So what's going on? Well, it's not your brain playing tricks on you. It's a trick of the light itself. And we're going to figure this little puzzle out right now.
All right, let's get into the science of it. This whole bending thing has a name, of course. It's called refraction. And trust me, it's the key to understanding, well, pretty much everything. Not just your straw, but how cameras work, how glasses work, even how your own eyes work.
So what is it exactly? Well, refraction is just what happens when light passes from one medium, that's just a fancy word for a substance, into another. Think about it. The light ray is traveling through the air, and then bam! It hits the water and has to change its path. That change in direction is refraction.
Okay, but why does it have to change direction? What's the big secret? It's actually super simple. It all comes down to speed. See, light is incredibly fast in a vacuum, but the moment it hits something denser, like water or a piece of glass, it slows down. And it's that sudden change in speed that forces the light to take a turn. And check this out, because this slide shows the two golden rules. Scientists use this imaginary line called the normal to measure the bend. So, on the left, you see light going from air into glass, from less dense to more dense. It slows down and it bends towards that center line. Then, on the right, it's going from glass back into air, from dense to less dense. It speeds back up and it bends away from the line. That's it. That's the whole game.
So we know light bends, and we know it's because it changes speed. But how much does it bend? Is it a lot? A little? Can we actually put a number on it? You bet we can. And that brings us to our next idea. It's called the refractive index, and we usually just call it N. All you really need to know is this. It's a number that tells you how much power a material has to bend light. And the rule is simple. The higher the number, the more it slows light down and the more it bends it. It's like a bending power score for every material.
All right, time for a pop quiz. Just to give you an idea, water has a refractive index of about 1.33. Glass is around 1.5. But what incredibly famous, sparkly thing has a ridiculously high refractive index of 2.42?
A diamond, of course. And what's so cool about this chart is seeing just how extreme that is. Look, air is basically one. It hardly bends light at all. You've got water, then glass, and then way out there is diamond at 2.42. That massive number is the whole reason diamonds sparkle so much. They bend light so intensely that they break it apart into a rainbow. It's all in the numbers.
Okay, so understanding this is cool, but where things get really interesting is when we stop just observing it and start controlling it. This is where we go from a neat party trick with a straw to building some of the most important tools in human history.
So what do we get? We get lenses. That's it. A lens is just a piece of glass or plastic that has been shaped in a very precise way to bend light exactly how we want it to. It's us taking this law of nature and putting it to work.
And there are really only two main flavors. You've got your convex lens on the left. That's the one that bulges out in the middle. Its job is to take light rays and bend them inward so they meet at a single point. It converges light. Then on the right, you have the concave lens, which is thinner in the middle. It does the exact opposite. It takes light rays and spreads them out. It diverges light.
And this diagram just makes it so clear why that happens. It's all about the curve. By controlling the shape of the surface, we control the angle that the light hits, forcing it to bend either in or out in a totally predictable way. It is just brilliant engineering.
All right, we can now bend light on purpose. So let's get to the grand finale. How in the world does this bending actually create an image? Because this is the magic behind a camera, a telescope, and you. Now, this might seem crazy complicated, but physicists have boiled it down to just three beautifully simple rules for a convex lens. Rule number one, if a light ray comes in straight and parallel, it gets bent through the focal point. Rule two, if a ray goes right through the dead center, it doesn't bend at all, it just goes straight. And rule three, if a ray goes through the focal point first, it comes out straight and parallel on the other side.
And with just those 3 rules, you can predict the future. Of light, anyway. You just draw those lines from the top of an object, follow the rules, and wherever they all cross paths on the other side, that's it. That's exactly where the top of the image will appear. You can figure out where it'll be, how big it'll be, and even if it'll be upside down.
In fact, this table is the ultimate cheat sheet for it. It basically does all the drawing for you. It tells you, hey, if you put an object way far away from the lens, this is the kind of image you're going to get. If you put it super close, you'll get a different kind. It's all laid out. Real, virtual, bigger, smaller, it's all predictable. And here's the big takeaway. This isn't just some physics problem on a whiteboard. These rules are the reason a magnifying glass makes things look bigger. It's why a camera can capture a picture. And it is literally how the tiny lens inside your eye is focusing light onto your retina right now, letting you see everything on this screen.
So that brings us to one last, kind of mind-bending thought. We started this whole thing with a bent straw, an illusion, right? And we ended up learning how we can use that same bending to create totally new images. So, if everything you see is just light that's been bent and focused by a little lens in your eye, what does that say about what's really out there? Kind of makes you think, doesn't it? Thanks for joining me.